Let's talk about what the idea of a limit is. So limit, this is the notation you're going to start to see. And the way you read this, there's multiple ways you can kind of move it around, but really it's just the limit as x approaches a of f of x is L. That's essentially what it is here overall. Now, what does that really mean? Well, it's approaching. So by approaching, that means that it doesn't actually have to be defined at that point. A limit is basically what's going on as you reach that point overall, okay? So visually speaking, if I was to give you some kind of graph, like let's say some kind of parabola with a little open circle here, and let's say this was 2, this was 3, and there was a point down here, 1, okay? If I asked you, what is f of 2? Well, we look at it and go, well, the points right there defined as equal to 1. Well, that's not what a limit is. The limit as you approach 2 of this function, okay? So as you are approaching, getting closer and closer to x is 2, getting close to x is 2, what is that y value it's approaching? It's equal to 3 in this case. And that's what it means by approaching in general. So if you're given, for instance, either a graph or a piecewise function, okay? Like let's say you're given something along the lines of f of x is equal to, let's go ahead and do it piecewise. We'll do x minus 1 when x is less than or equal to 1. We'll do x squared plus 3 when x is between 1 and 2. And we'll do 5x when x is, let's say, greater than or equal to 2. And you could be asked several questions. You could be asked, what's the limit as x approaches 1? And you start to see these little pluses and minuses after the number. And you're like, what is that? Well, what that is it's called a one-sided limit. So these right here are one-sided because it comes from one side. And you might hear coming from the left and coming from the right. The way I like to think about it is like think about numbers that are approaching from less than 1 versus numbers that are approaching from greater than 1. So numbers approaching less than 1 would occur here. And so you start by directly substituting in a 1. If you do that, you get 1 minus 1 is 0. So from the left end, you're going to get the y value is 0. On the right end, when it's approaching from greater than 1, well, that's right here when it's greater than 1. If you would substitute in right here and plug in a 1 for x, you get 1 squared plus 3 is equal to 4. Now, the limit as x approaches 1, well, if you were asked that just by itself, in this particular case, you'd actually have to consider each individual side for the piecewise function. And in doing so, since they don't match, you would actually say the limit d/e, which stands for does not exist. Where's the e? Where's the e? From the e in. E, there we go. And the reason why it doesn't exist is because you can't tell me a single answer. Now, if it was like something like 7 and 7, the answer would have been 7. They all would, meet at the same place. But in this case, since they don't meet the same place, it would be d and e, does not exist. And another point to consider is a lot of times here, okay, so do I always have to like break it up? And it's on certain cases. Like if I gave you the limit as x approaches 3, for example, you don't have to do coming from the left and coming from the right because I know it exists somewhere over here and it doesn't break up. When it breaks up, like going from 1 to 1 or going from 2 to 2, then yeah, you have to look at each side if you're asked the two-sided limit here. But in this case, you would just go ahead and plug in a 3 for x where it's located, and 5 times 3 gives you 15. So that's the start of a very long conversation you're going to be having with limits.